Hey guys, today we're going to talk about limiting and excess reactants. So I just want to give you guys a real world example first because these are very applicable to the real world. This is something you could really actually use later on in life. Um, let's think about you are in charge of inventory at a car factory and you order 18 tires, 2 steering wheels, and 30 windows to build 3 special edition luxury cars. Each car requires 1 steering wheel, 4 tires, and 6 windows. I want to know why you're in trouble with your boss. Give me 2 reasons why you might be in trouble with your boss if this is what you ordered and this is what it takes to make a car. Think about that for a second. Just pause and think about it. What you should have come up with is the fact that you can only build 2 cars. You've only ordered 2 steering wheels. Because you need 1 steering wheel per car, you'd be able to build 2 cars with 2 steering wheels. So this number of steering wheels gives you 2 cars. Well, with 18 tires, you'd be able to build 4 cars with 2 tires left over. But if you're only going to build 3 cars, you're actually going to have, 6 tires left over. With 30 windows, you could build, 5 cars. Since you only are going to build 3 cars, that would leave you with, you need 3, 18, 12 windows left over. Okay? But because you only have these 2 steering wheels, you are limited to 2 cars, even though you have plenty of this other stuff. So you have tires in excess, you have windows in excess. You are limited by steering wheels. Now, here's the deal. First of all, you can't build the 3 cars that you said you'd build because you didn't order enough steering wheels. Second of all, you're going to have, either way, you're going to have tires left over. Tires for luxury cars are super expensive. Your boss is not going to be happy that you've wasted this money because if it's for a custom car, there's nothing to do with those tires after that. Same with the windows. You're only supposed to build 3 cars. You ordered 12 windows too many. Think about how much windows are going to cost for these luxury cars. And there's no other car to put them on because these are custom. So this is very real world applicable again because people use this all the time when they're ordering for their companies. There's all kinds of things you'll do this with if you work in the pharmacy industry, anything like that. But this is what limiting and excess reactants are all about. We're just going to put it in chemical terms. So limiting reactants or reagents, sometimes you'll see that word, limit the amount of product produced. They cause a reaction to stop. You run out of it. So when you're talking about cars, you ran out of steering wheels. It caused production to stop, and it limited the amount of product you could produce. Excess reactants are the reactants that are left over. So in the case of the cars, the steering wheels and the tires and the windows were left over when the reaction went to completion or production had to stop because you were limited by steering wheels. Of course, this being chemistry, you know it's going to lead to math. So we're going to learn how to find the limiting reactant and the excess reactant. And for that, as always, you're going to need a balanced equation. So I went ahead and used this one. 6CO2 plus 6H2O gives you 6 C6H12O6 plus 6O2. Just make sure. Yeah, that balances, right? So if you have 88 grams of CO2 and 64 grams of H2O, your reactants, which is the limiting reactant. To find that out, and I would be writing this down as I go, so pause as you need to. You're going to convert both of the reactants to moles of one of the products. Either product is fine, okay? So I can figure it out to glucose or to oxygen. However, look further along usually because often the question is going to continue where it asks you about a specific product. So if I look down here, eventually I'm going to ask you what mass of oxygen will be produced. So it would make sense for me to go ahead and use oxygen as my product now because I'm going to have to get to it later. So we're going to convert both of the reactants to moles of one of the products. So our 2 reactants are 88 grams of CO2 and we have 64 grams of water. Now, I'm going to convert that to moles of the product. So we're just going to do our stoichiometry. CO2 has a molar mass of 44.01 grams per 1 mole. Since we are converting that to a product, we're going to go to O2. So we're going to have to do our mole ratio. So looking at our mole ratio here, it's a 6-to-6 ratio. So we've got our 6 moles of CO2 on the bottom. We've got our 6 moles of O2 on the top. Now, you can stop there and find the number of moles. You could continue on to grams if you know that's what that's coming up, for those of you who kind of get what I'm talking about. So 88 times 6 divided by 44.01 times 6. That's going to give us 1.999, so it's really going to be 2.00 moles of oxygen is how much oxygen can be made from 88 grams of CO2. Now we need to do the same thing with our water. Oops, get my pen right. All right, molar mass of water is 18.02 grams of water. Again, make sure you are writing your units and your formulas in your work so you don't get confused. All right, so we've got to do that mole ratio again, and it's another 6-to-6 ratio. That is nice. So really that's a 1-to-1, so you could simplify it, but I just don't because I don't want to confuse anybody. So 6 moles of H2O to every 6 moles of O2. So I'm going to do 64 times 6 divided by 18.02 times 6. And if I have 64 grams of water, I can produce 3.55 moles of oxygen. So clearly the reactant that limits our amount of oxygen production is this CO2. It only allows us to make 2 moles of oxygen, whereas H2O, 64 grams of H2O, allows us to make 3.55 moles of oxygen. So you can see it doesn't matter which you have more of, okay, because of molar masses and stuff like that, it's going to come out, in this case, that CO2 is our limiting reactant. Now, be careful. Don't sit there and tell me oxygen's your limiting reactant. That's your product, okay? We're using this to figure out which of our reactants was limiting. So that means water is your excess reactant. Now, often a question will also ask, what mass of product will be produced? So in this case, what mass of oxygen will be produced? So if I knew that ahead of time, I could have just taken these both out to grams and compared and chosen the smaller one. But since I know carbon dioxide is my limiting, and I've got carbon dioxide gives me 2 moles of water, I can just start with that, 2 moles of oxygen. I can start with that 2.00 moles of O2, and I'm just going to convert that to grams. So that's going to give me 64.00 grams of oxygen. Okay, that's the mass of oxygen that is produced because our limiting reactant does that. Again, I could have taken these both out to grams and had my answer already, but either way it's fine. Now, how much excess reactant do we have left over? That's the next question we have to answer. So what we're going to do to find out how much excess reactant we have left over is we're going to use stoichiometry to convert our limiting reactant to our excess reactant. So what we knew was our limiting reactant was CO2, and we had 88 grams of it. So that's where we're going to start. So 88 grams of CO2. And we're converting that to our limiting reactant, which was H2O. So we're going to do our molar mass of CO2 then we have to do our mole ratio, and looking back, you know the mole ratio of CO2 to H2O is 6-to-6. Look at your balanced equation. And then we are going to continue and take that H2O out to grams. All right, so 88 times 6 times 18.2 divided by 44.01 times 6. And I get 36.03 grams of H2O. Now, what this number is tells me the amount that was used. This is not the amount left over. This is how much H2O we used in the reaction. So when we had our 88 grams of carbon dioxide, we will use up 36.03 grams of water to get that 64 grams of oxygen as a product, okay, to make this go to completion. To find out how much is left over, well, at that point, you look at how much water you started with. We started with 64 grams of water. We used 36.03 grams of water. So that means 64 minus 36.03, 27.97 grams of water left over. Sometimes this is said to be in excess. Okay, so that's probably fine if it's water, because water's cheap. I don't have to worry about that. However, if this was gold, you have 27.97 grams of gold left over, and it's unrecoverable because it's been contaminated by the other reactant, well, that's going to be trouble because you've just wasted all of that. So in real life, you have to do all the math beforehand to see how much of each reactant you should use to have the least amount of leftovers when your product is made and to make the amount of product that you want to make. And you can use stoichiometry for all of that, and people truly do. Of course, in something pharmaceutical, it would be chemicals, but in something real world, it might be, how much yarn and knitting needles to make hats. I don't know, something like that. But anyway, that is limiting and excess reactants. We will learn how to do theoretical and percent yield in another video soon. All right, have a great day.